80,000 years ago, in the middle of Ice Age Europe, there was a group of humans living in temperatures like northern Sweden today. They had no fire. Not for a night, not for a winter. Generations of them lived and died without ever sitting next to a flame. And the reason they had no fire is the exact opposite of what you'd expect. I'm going to show you the archaeological evidence from two caves in France that broke the story we all got taught in school. Because here's the thing we assume. Fire is the beginning. Caveman discovers fire, cooks meat, brain grows, civilization happens. One spark, one moment, and we're off. That story is wrong in almost every part. Fire wasn't a discovery. It was a resource, something you found, carried, and lost. For most of our history, humans didn't own fire. They borrowed it. And those Neanderthals in France? They had plenty of fire during the warm periods, and almost none during the coldest ones. Backwards. Completely backwards. The explanation for that is the most unsettling thing in this whole video, and it says something uncomfortable about knowledge itself. I'll get to it. But first, you need to understand the problem fire was actually solving. Forget warmth for a second. The first real problem was food. Try this thought experiment. Raw goat meat, not a steak, wild game, stringy, elastic. Harvard evolutionary biologists Catherine Zink and Daniel Lieberman actually ran this experiment. They wired volunteers up with sensors on their faces and made them chew raw goat, raw beets, raw yams, measuring every single muscle contraction until they could swallow. The result for a big piece of raw meat? You chew and basically nothing happens. It just gets more elastic. Your jaw loses. Now here's the number that matters. When they sliced the meat and pounded the vegetables first, no fire, no cooking, just a sharp stone, people needed 17% fewer chews and 26% less chewing force. Scale that up over a year, and Lieberman calculated it saves you roughly 2.5 million chews. 2.5 million. From a rock. That's half the answer. Homo erectus, 2 million years ago, had a bigger body and a bigger brain than anything before it, and needed way more calories. But it also had small teeth and a weak jaw, basically like yours. How? Because the food was being processed outside the mouth, not by fire, by a sharp edge. And the timing is the part nobody mentions. Cutting tools show up at least 1.5 million years before cooking became common. Now there's a famous counter-argument here, and it's worth understanding because it's one of the biggest fights in human evolution. Harvard anthropologist Richard Wrangham says none of that is enough. His position: we didn't invent cooking, cooking invented us. His evidence is arithmetic, and it's brutal. Wrangham and his colleagues calculated that Homo erectus would have needed to eat about 12 pounds of raw plant food every single day to survive, or 6 pounds of plants plus raw meat. And even eating meat at a chimpanzee's chewing rate, erectus would have had to chew for 5.7 to 6.2 hours a day. Think about that. 6 hours of chewing every day. That's not a species building anything. That's a species with a full-time job in its own mouth. Wrangham's point is that brains are absurdly expensive. Brain tissue burns about 22 times the energy of skeletal muscle, and Homo erectus had a brain 50% larger than the species before it, plus the single biggest drop in tooth size in our entire evolution. Something had to be paying for that. His answer? Fire. Cooking. By 1.8 million years ago. There's just one problem, and it's a big one. The fire evidence isn't there. Most archaeologists say controlled fire that old simply hasn't been demonstrated. And there's a rival explanation that needs no flames at all: the expensive tissue hypothesis from Leslie Aiello and Peter Wheeler in 1995. Energy-dense animal foods, bone marrow, brain matter, fatty scavenged tissue, small gut, big brain, no fire required. That fight is still unresolved today, which brings us to what we can actually dig up. Because discovering fire implies there was a before and an after. There wasn't. There were stages, and each one may have lasted hundreds of thousands of years. Stage 1. Not running away. Primatologist Jill Prutz studied chimpanzees in West Africa living around seasonal wildfires. What she found is that chimps don't panic. They watch a wildfire move. From a few meters away, they predict where it's going, and then they walk into the burnt ground afterwards to forage. They can't build a fire. They can't contain it. But they understand it. They've lost the fear almost every other animal has. That's stage 1. Our ancestors were probably there millions of years ago. Stage 2. Picking it up and carrying it home. And this one is much older than most people think. Wonderwerk Cave in the Kalahari Desert, South Africa. In 2012, researchers published evidence of fire there from around 1 million years ago. At the time, the oldest solid evidence in the world. A new study published in 2026 pushed it back further. Traces of burning in layers dated between 1.07 and 1.79 million years ago. Likely Homo erectus. Here's why that evidence is so hard to argue with. The burnt material was found roughly 30 meters deep inside the cave. A wildfire cannot reach 30 meters into a cave. Lightning cannot strike there. There is no natural mechanism, which means someone carried it in. Someone picked up burning material from a savanna fire, walked it into the dark, fed it, and kept it alive. Repeatedly, across different occupations. But the researchers are very clear about this. That is not the same as making fire. They were harvesting natural fire, lightning strikes, savanna burns. And that caution matters because a lot of very old fire sites turned out to be nothing. The famous 700,000-year-old Homo erectus hearths at Zhoukoudian in China, later analysis showed those were natural sediments that just looked like ash and charcoal. So when does someone finally, provably, cook something? Northern Israel. A site on the Jordan River called Gesher Benot Yaakov, 780,000 years ago. Excavators found something strange in the layers. Around 40,000 fish remains, and more than 95% of them were teeth. Where did all the bones go? The answer is that cooking softens fish bone. Soft bone decomposes. Teeth don't. So a pile that's almost entirely teeth is exactly what a cooked meal looks like after 780,000 years. But that's an inference, so the team tested it. They ran X-ray diffraction on the tooth enamel because the nanocrystals in enamel expand when they're heated, and how much they expand tells you the temperature. The crystals showed heating to under 500 degrees Celsius, and that low number is the whole discovery. High heat would mean the fish were thrown into a fire as fuel or as garbage. Low, controlled, moderate heat means someone was cooking. The researchers think it may have been earth ovens beside the fire, possibly with the fish wrapped in water lily leaves from the marsh. Giant carp, some of them 2 meters long. Before this, the earliest firm evidence of cooking was around 170,000 years ago, and everyone assumed that meant Homo sapiens. This pushed it back by more than 500,000 years, to a hominin that wasn't us. So fire is being carried by 1.8 million years ago. Food is being cooked by 780,000. Real hearths inside caves become common around 400,000. Which makes what happened in France almost impossible to explain. 2 caves in the southwest, Pêche de la Zaye 4 and Roc de Marsal, excavated over 10 years by a team including archaeologists Harold Dibble and Dennis Sandgaith. Neanderthals camped in both from about 100,000 to 40,000 years ago. The bottom layers, the oldest, were full of fire. A 40-centimeter thick band of charcoal and ash. Dozens of hearths at Roc de Marsal, so well preserved they looked days old. Thousands of stone tools, many accidentally burnt by nearby fires. Then they dug the upper layers, and the fire just stops. The first assumption was erosion, wind and water washing the ash away. But here's the detail that kills that. Almost none of the thousands of stone tools and animal bones in those upper layers show heat damage. Wind cannot selectively remove burnt objects and leave the unburnt ones behind. The fire wasn't washed away. It was never there. And the dates are the problem. The layers with fire are from a warm period. The layers without fire are from 70,000 to 40,000 years ago. Glaciers spreading across Europe, some of the coldest conditions Neanderthals ever faced. They stopped using fire exactly when they needed it most. So why? It's not fuel. Wood is scarcer in the cold, sure, but bone burns. Bone was used as fuel at Tesh 4, and bone was abundant in both periods. There's really only one explanation left. They couldn't start a fire. They could carry it, they could feed it, they could keep it alive a long time, but they could not create it from nothing. So they were completely dependent on getting it from the outside world. And where does natural fire come from? Lightning, which is dramatically more frequent in warm conditions than cold ones. Warm period. Lightning strikes, wildfires burn, there's fire available to grab. Cold period. The sky goes quiet. No lightning, no wildfire, no fire. That's it. Their fire supply was literally the weather. And think about what that means. These weren't stupid people. Neanderthal brains were as large as ours. They just held a technology they could receive but not produce. So when the source dried up, the technology went with it. Not slowly, just gone. For tens of thousands of years. The clearest signs of actually making fire come much later. Neanderthal hand axes in France, with wear marks suggesting they were struck against pyrite for sparks around 50,000 years ago. So, how did ancient humans survive without fire? 3 ways, and none of them are romantic. 1. They processed food instead of cooking it. Sharp stones did the work heat does now. Sliced meat, pounded roots, 2.5 million fewer chews a year. 2. They leaned on raw, high-density food. Meat, marrow, fat, calories that are worth eating cold. 3. Their bodies were built for it. And this is the part people get wrong. Neanderthals weren't just enduring the cold. They were shaped by it. High body mass, broad, barrel-shaped chests, short lower arms and legs. Every one of those traits reduces heat loss. They were, anatomically, cold weather animals in a way we simply are not. There's also an older idea, that they were far hairier than we picture them. And I want to be straight with you. That one is still speculation. The body shape is solid evidence. The hair isn't. And here's the line that stays with me. We are what researchers call obligate fire users. Take fire away from modern humans, all of it, including everything downstream of it, and we don't manage. We cannot survive without it. Neanderthals had no such dependence. In the middle of an ice age, in the dark, in the cold, without a flame, they were fine. They weren't waiting to discover fire. They just didn't need it the way we do. One thing I want to know, because the comments on this stuff are always better than the video. If every fire on Earth went out tonight, and you had to restart one, could you actually do it? No lighter, no matches. Tell me honestly in the comments. I read all of them. Because the follow-up question is the one that actually bothers me. Neanderthals had brains as big as ours. They survived ice ages. They lived across Europe for over 200,000 years. And then they were gone. That's the next one. It's on screen now.